work over energy तवरजे work over energy ये number 1 formula number 1 दा कही ले work ने verbally ने हाया वक्कदी और verbally ने हाया के को number 1 दा formula number 1 page number 13 work done by a constant force will be equal to, that means we have to find out the dot product between the force vector and the displacement vector. Dot product कमाएं ना आएंगे अब इस पानी ये करो F vector is equal to 2I cap plus 4J cap minus 3K cap, and your displacement vector D vector is equal to 2 minus 2I cap minus 5J cap plus 2K cap. See, combined tarni ba work done will be equal to force dot D vector and as क्या ना होगा scalar पर energy से can we calculate the can we locate the direction of energy work done की mark direction ले पे आपने यहाँ देखो energy की direction ले जितना भी ना सीधे यहाँ बता रहे हैं अब क्या आंसर आंसर क्या था नहीं 2I cap plus 4J cap minus 3K cap this will be the product of minus 2I cap minus 5J cap plus 2K cap. In short, हमारे यहाँ बता रहे हैं work done or energy. Work done or energy is a scalar quantity, so we must find out the dot product between the force vector and the displacement vector. Okay. And how to find out the dot product? It should be with respect to the identical unit vector. I cap must be multiplied with I cap. J cap must be multiplied with J cap. K cap must be multiplied with K cap. So it will be 2 minus 2 it will be minus 4. This is plus 4 and this is minus 5. It will be minus 20. This will be how much? Minus 6. So all together it will be equal to minus 30 joule of work done. As horrible. याद नहीं को? ना work done को क्या है तार की vector notation हमारे यहाँ बताया कि work done और energy will be same and it should be the dot product between the force applied and the displacement produced. Here, if a body, this is body, see body में देखो, this is being acted upon by this force F. Now, the body changes its position from this original to this initial position to this final position. The change हो रहे हैं. Therefore, this will be denoted as displacement vector. So, whenever the applied force produces or produced some displacement will produce the it will be said to have work done नहीं है याद है ना ऐसे कहेंगे को so let us come to our conclusion the laxi what are the different types of work done हमला आसिको number 1 था positive work done. This is the example for your positive work done. Positive work done is said to be done when the force applied produces displacement in the direction of the given force. ऐसे क्या होगा? माना force ना apply तो reverse direction to the displacement produced होता है, it will be considered as positive work done. Okay, understand the one में? Next हम second हम लास्ट को second ना negative work done. Let us consider the same diagram. Consider this is mass m. This is moving with this moving with initial velocity d and it produces a displacement d. Now, if the surface is rough to bata d, what must be the direction of friction? Friction की direction निकला होगी नहीं? It must be to the left. Final आखिर understood the one को. So, what must be the work done? The work done by the frictional force will be equal to work done F dot d s vector or simply d vector. And what is the angle between these two? My angle is क्या होगी ऐसा? 180 का bro. 180 होता है here f d cos of 180, and we do know that cos of 180 is equal to -1, so it will produce minus f e of the understand the one very simple way when the applied force produce your displacement in its application in its direction of application manasi force applied to the direction to the displacement produced totally it will be positive work done, and if the force is in one direction and if the displacement is in the opposite direction, then the work done is said to be negative work done. The work done by the work done by frictional force will be considered as negative work done. Okay, and what about zero work done? Next, let us consider zero work done again. Let's go. So the angle is displacement is along this direction, force will be along this direction, so theta will be equal to 0 degree. So if we write the same expression, work done will be equal to this is f into your displacement d into cos of 0. That means it will be positive f d n illustrate in terms of mathematical calculation and in terms of your understanding. Reality force applied to displacement same direction cos of 0. Okay, and our answer will be positive if the force applied or if the force is opposite to the displacement, as in the case of friction your angle will be 180. Okay, angle will be 180, so it will produce negative work done. And what about the zero work done? Zero work done is very simple. If the force is in perpendicular direction and the displacement in the another direction, this is f and this is d. What must be the angle here? Theta is equal to 90 degree. Then our work done will be equal to f d cos of 90 degree, and this will be equal to 0. Work done will be positive, negative, and 0. Okay. Now let us come to the very important conversion factor. Mega electron volt. Formula book 1 joule is equal to 0.7 arc. This is not so important. 1 electron volt is equivalent to how much of energy? The energy possessed by 1 electron will be known as why do electron possess energy? Electron is moving around the nucleus neutron, so it must possess some kinetic energy. Okay, that kinetic energy will be measured in terms of electron volt. Okay, energy possessed by the charged particle will be measured in terms of electron volt, and 1 electron volt will be equivalent to 1.6 into 10 to the power minus 19 joule. Okay, and what about the mega electron volt? Mega electron volt will be equal to 10 to the power 6. Mega means क्या माने है बा? अंतर आएगा से हाइब्रिड के सी के आवे बा 10 to the power 3 से कहीं कोई kilo. Yani ko 10 to the power 3 will be known as kilo. 10 to the power 6 will be kari ko gani ba? Mega. 10 to the power 9 di kya ko gani ba? Ha. Kari ko ba se? Kari. Kana hai ro ne. Simo ko ma ko ro. Sei hai ro ne. Si ko tak khamu ko. 10 to the power 10 di kya no se? Ani jinu ko zero. Yabra. Minus of 10 to the power 10 to the power minus 3 is take away. This will be milli. Yeah, 10 to the power minus 6 take away. This will be known as micro, and I write bro micro. Sino ya tum singiri sundalo ko. Siya ing lagi kayo kung calculation ko the use to the next 10 to the power minus 9 is take away. This will be your nano. Last time I did 10 to the power minus 9 will be nano, and this will be denoted by small n. 10 to the power क्या लागो से minus 10 के मनाली से angstrom angstrom, and this is represented by a with 1 degree. hangani ko 10 to power minus 12 ti kay gawin so kay okay by 4 and it will be represented by small p and what about 10 to power minus 15 ha hem to likely army ko ra với là chemistry là Enrico Fermi na tamo kanina dai ko kasi na siba ada yung zero don't tell you adi mega height adi 10 power 6 lakh na to so 10 to power 1.6 into 10 to power minus 19 is multiplied with 10 to power 6 we will be getting our answer as 1.6 into 10 to power minus 30 dari ko adu kamu phai maru ise last it is a conversion factor how to convert 1 joule in terms of mega electron volt se si bahar to the sungya dekho si bahar to the yaro 1 joule will be equivalent to 6.25 into 10 to power 12 mega electron volt now formula ko yaad ro this is already written in your formula book si underline to ko mo barate Similarly ko 1 ay siya bet so kami ige kasi ang tawag pala no is nagto natin ni 1 the 1 joule will be equal to 6.25 into 10 to power 12 mega electron volt siya maruwe conversion of mega electron volt to joule sina para easy hoy how to convert your joule in mega electron volt si magi numerical conversion factor se difficult way remember to hoga याद ना electron volt भी था कि how to convert electron volt is very simple 1 electron volt will be equal to 1.6 into 10 to power minus 19 joule like iba abra this is very easy hangi ko however converting your joule in terms of electron volt or mega electron volt is difficult way ko so you have to memorize 6.25 into 10 along with then the standard then 10 to power notation this is bha pugdom ni ko याद ना hange adu di barbelli we harige what are the two different type of energy kinetic energy and potential energy le to the energy possessed by the moving object will be kinetic energy the energy possessed due to position will be known as kai ko baneba your potential energy hierarchy and now is the short one I have to talk me ko ase this is gravity this is the surface of the earth we have one body of mass m and this is to be shifted to a height is shifted down then how much work then will be required to change the position of this object from the surface of the earth to a particular height is sino ma pala kya ta dikya awadi what will be the work done the work done will be equal to mgis ka hoya dekho and this work done will be converted in the form of potential energy what I am trying to illustrate is that whatever the work done said, it can be either converted into potential energy or kinetic energy depending upon the motion or depending upon the position of the object. Understood the way? Habit sila ay natawag yung tawag sa NC para fine lang niyo. For some of the I am doing some certain amount of work and if this work done produce the motion then the work that is done by me will be converted into kinetic energy. Understood the way? Sige object amo sa makadal rembi niya sige mag ground floor na rembi sa ay na si Victoria while lifting this notebook from the ground up to this certain height after lifting to this particular height as lift to the body is at rest labra so the work done will be converted in terms of another convert hogani potentially convert hoga understood tawre yaadra hangi ko adudi now let us come to your formula number 5 ta last ko work energy theorem la bro formula number 5 work energy theorem ado kinetic energy ki na kari hai base kinetic energy ki na half mv square ta bata da bro isliye the pillar or me ta ke to simple lage ko ado here work done kare base work energy theorem ki kari hai the work done will be equal to kana manai change in kinetic energy very simple ragna yaru to sikhane ko se adudi how you write the work energy theorem Work energy theorem can be written as the change in the kinetic energy. Initial kinetic energy, sorry, final kinetic energy minus initial kinetic energy. That is written in your formula number 580. Understood, Tamadra? There is a conservative, non-conservative, and the central force. Si Sumtang barheli when higher Yagaga Hayagiko. Conservative force Kanaka depend however, conservative force will depend only on the initial and the final position. It will not depend on the path. Path depend on example in the higher say. See there, this is conservative force here. The gravitational force, so it will be known as conservative force. Here, let us consider this is 1 1. W1 in color 04. The work done that is required for changing the position of this object from this ground floor dagina top floor to change the work done is W1 in color. Now, let us consider or let us take this same object by taking this part number 2. Part number 2 is part number 2 is minus around this is 2. What will be the work done W2? It will be still W2. W2 will be exactly equal to W1. Do you understand the concept here? Since these two different parts, straight part and the C-curve part, two different parts, it will produce or it will generate the same amount of work done. Then I say same amount of potential energy. Why? Because their initial and final position are same. W1 will be equal to W2 and it will be equal to mg. If the work done is dependent only on the initial and the final point, then that type of force that is required will be known as conservative component. Yagata? I has conservative high target initial ka final ka depend and it is independent of the path taken. Yagata? My example to Nico, concept is very easy to remember. Now, Nangi Sida in underline Singum system how in the Pugatare. Gravitational force conservative or conservative or electrostatics electrostatic force conservative or elastic force conservative or restoring force due to spring spring springy force time kasi walk over energy tackle ni mati kasi yang itu ko sidang ka harus electricity ki kamay harus this is q1 q2 na product bro this is your r adi what will be the formula f is equal to k is ka yung manay 1/4 epsilon na lakh na bro ay sidino na familiar o na kilometer tang sudan k aga K into this is Q1, Q2 divided by R square and what about your gravitational force M1, M2 lakra? This is R. Then what about your F? F will be equal to G. This is M1, M2 divided by R square lakra. Like, and now what about this magnet? This is magnet of pole string M1. Pole string M1. This is North pole, this is South pole, and this is of M2. This two are separated by distance r. Then what would be the force? 1 by not 1 by, it would be mu naught by 4 pi into this is m1 m2 divided by r square lakra. Si discuss lakre ko se tang mo nga tani sina kay ko se electrostatics chapter number 1 class 12 ki khangi ko sina class gravitational force na class 11 ki chapter number 7 yani adu sita kara tami magnetism da tami ko magnetism sitam da brane udri bo si mo ganam ko udri ya rata hi si udri ya rata sapa ne ba loy mo ne copycat nga tani use Newton ji da ne copycat ngata le to reason de demo chapter man 1 by r square. What is common to all these three formula? Si formula de kari hoy sina magnetism ni sina charge kini adu di charge ka magnet ka ni pull up to kai hai ni se electromagnetic force na ko ngara hai gi bhai do bro. Electro it is related to charges hangani ko magneto hai na magnetic hai na it is related to magnetic la idna aduna clear man basically having is kaino koi Tesla in hai na Tesla je koi car maming ni hai tu rawa ya car maming is su ko adu ko magi unit se kari hai ne se magnetic field ki unit na to ya bro sima di scientist to kari maming ko ba Nicholas Tesla and Handato mana kari pointer meba electromagnetic force pointer. That means electrical force can be converted into magnetic force and the reverse or vice versa is also correct. Magnetism dagi electricity generate tawya ni electricity dagi magnetism generate tawya ni gagata koina some the example ma pige electric motor sigi magi function se kaino motor kai toge electrical energy is converted into mechanical work done dabra generator na kari hoy your mechanical work done is converted into electrical energy have not that is there is interconversion se kana na hoy dino that is from electric field to magnetic field to electric field and it follows the same formula 1 by r square follow tawra tawi yan dai ko hai se adu di here very simple oina nang khang du sa sigi three different formula electrostatic formula magnetic formula and gravitational formula je they all follow 1 by r square follow tawra tawi if any force follow 1 by r square, this is known as inverse square law. Inverse square law follow by it will be conservative. Without any consideration, you close your eyes and say it is conservative. Yagata, I has come over bro. 1 by r square I think it is inverse square law and 1 by r square simply it will be conservative. Yadra. Yareko aduga and the conclusion is that only the conservative force field will generate potential energy. Potential energy je kanana generate tawani id it will be associated with conservative force only. Do we study potential energy in our frictional chapter? No. Potential energy of the charges we have studied in your class 12 the potential energy discussed we and energy stored in a solenoid we discuss it in magnetism. Okay, tami aduga do we discuss the potential energy arts gravitational potential energy we discuss in your gravitational chapter tami ko adugi what is to be remembered kaino your conservative force field will be associated with potential energy. That is the final point to be remembered. Yaga and ko potential energy kana associated tabani potential energy will be associated only with conservative force field ka legani. That is why yesterday ngarang why na takugo the spring ma laitati what will be the extension is x. This is force F in the color tadi according to Hooke's law it will be kx and lakro bro. And what about the potential energy half kx square and equal to bro. Adu di mag sidam p is kay pyramid spring is your the bro. Adu here kayo gani potential energy will be stored in the spring. Yani hange next the last time asi non conservative na kanada depend tawi force path depend to bro. Example in hai friction se kayo hatari that will be kreva non conservative. Yung ay na si friction le na tra mana kitang ka rap to di ka dawi ay kusi am taloy ba sige mana ya sang han nan to ta di kit will be generated na tro understood to bunga mi ko yan siya it is dependent upon the path depend to greater the path more will be the work done. Understood to right jarani ko non conservative will be dependent on the path taken. Yagadra? Yarani, example when kana remember to guneva nagi discuss for second I discuss tawi. Kari chapter de आओगे इसको सीखी से कई चैप्टर de आओगे इसको सीखी से कई चैप्टर de आओगे खंड भी नहीं लिखित आओगी न तो and properties of matter da koina properties of solid liquid and gas tam manatra simple ni koina ahan da nangi Young's modulus tami bulk modulus tami modulus of elasticity tami na that will be related to your properties of solid hangani ko second da hydrostatics ka hydrodynamics ka tami na that will be related to kanada properties of solid properties of liquid hangani properties of gas kana discuss tawi nangi thermodynamics hai it is all related to properties of gas yatra hangani ko adu si am tang harang gi adu ko calculator je akana wala jira adu ko kodam take conservative ki sira maka bi formula number 7 je let us do it later is equal to for time being let us calculate your question number 1 2 3 4 निकोलसी क्वेश्चन नंबर 1 से आंसर क्या आता था कि हफ्ते हेरो मरदे रो ना हेरो normal mana hari se normal force and high right bro normal height are the perpendicular to the surface or perpendicular to the displacement of the ground answer will be 0 amtang yung se mana hari se a body of the mass m is standing on one end of a plane of mass m length l floating in water si water ne lakhala 0 ko si water lay din atra buoyant force si nupa si karon chalani person walk to vision in this direction that means displacement is to the right only go and what about the buoyant force to come where will be vertically downward and what about the normal direction will be in this direction so this is perpendicular to the bro understand the umami other here theta is equal to 90 degree and this will be equal to nagi wakan is equal to 0 ta tarotro example ne em hagi ko kogi lever kanguna mag heta object ra ha pag chalidra the weight or the force will be vertically downward mag is the lever ne nakhala now let us consider this is manual lever ne nakhala ko mana 5 kg maje mag ko pure and he moved to the right direction so the displacement is along this direction and what about the weight of this object the weight of this object is vertically downward that is 5 into 10 macro and what will be the work done is equal to 0 in our physics study physics की formula study work done is equal to 0 so you will not get your waste nan paisa piro hai ta fugai na rane ya ta bai hai se ai khang ko hai se habiti 0 work done ho gani anything that is carried by your head nan simat nan ko ka thamaga fare pura ta pose work done 0 yabra yarani ko answer will be 0 tabra hai gadra next term ye ko question number can use to receive question number 3 2 ai what ke ko si sim ya ro sim do ja ni da si sim ja ni no main direction ai bro mata p is the no main direction ai na pira mani da maka last line to ko no main hai perpendicular ho ta 0 ta din tro next up question number 3 की आंसर जो क्या आता लगता है what is the displacement after one complete rotation circular motion that we will be having your linear displacement along with angular displacement okay so it will produce or it will generate zero displacement la kadra la draw see one complete rotation square tum chalu re khala jeba one complete rotation chalu tardi in terms of your linear displacement the log tardi it is 0 because your final and the initial point coincide with one another. Okay, I ngang takum naham takum tam the for circular motion there will be two type of displacement high the bro. This is theta will be known as angular displacement and this will be linear displacement have the throw once amuktan complete your initial and the final coincide with one another. So in terms of linear value the linear displacement will be equal to 0 tabro. If linear displacement is equal to 0, work done is equal to work done the smiley brane work done equal to the force into set theta kani brane ide kamani f dot your linear displacement and even a throw. So we should not consider about the angular displacement. What about the angular displacement? Angular displacement will be 2 pi tabra. This is one way of explanation or one way of understanding. What about another explanation? Atopa explanation kamai haigani. Antang hairo. Sina this is in terms of kanado say linear explanation. In terms of your linear explanation and in terms of your circular explanation is kamai haigani sa very simple na sigi forcing mami take away centripetal force ma haire magi expression ni kai gamale si ka hoga de hairo ka hoga de what is the expression here ha AC adu dai hairo it should be m omega square r or it may be written as mv square divided by r. That is your centripetal acceleration will be omega square r provided that r is the radius and this will be v square by r. Understood? Your centripetal acceleration is the acceleration that acts towards the center. If the acceleration is multiplied with mass multiplied by it will be force. And what about the linear displacement? This will be your L. Still 0. Displacement if we consider for a small displacement this is the tangent tangential velocity vt or at tangential acceleration linear acceleration and when this object flies off this circular object when it flies off it will be producing your displacement along this tangential direction. I have already explained this. Understood me? This is the direction of your displacement linear displacement. So this linear displacement makes an angle 90 degree with the centripetal force theta is equal to 0. So our work done will be equal to 0 explanation will be work done is equal to centripetal force into displacement L into this is cos of 90 and still our answer is 0. Understand the question number 3 given answer 0 now let us do your question number 4. Question number 4 is itu mantra. Apply the reverse force to push la pull la push ni ko kita start hai push ki matlab jadli ko kahi hai we have to extend like this. Our diagram should be drawn by changing the position in order to have a better understanding of the diagram se line matlab koi na sigi line of action is kept constant or kept by original this will be your f if this angle is capital this is theta here this angle will be kya tarani sir? This is also again theta tabra. This will be your mg ma tagada tawoi bro. I actually come bro. Malas is there. Nangi before resolving this externally applied force F and result of this body will be acted upon by two different type of forces. Number one, the weight, its own weight mg. And what about the normal direction? The surface will produce normal direction in this direction. And the third force, no, external pushing force, and it makes an angle with the horizontal. So, in order to have a better understanding of our diagram, we change the position of this applied force over here. Now, what will be the component over here? The component of this applied external force will be F cos of theta over here, and another will be F sin of theta. Understood? Now, as this surface is rough surface, it will generate frictional force in this direction. F understood? Man, what is being asked in the question? What is the work done that is produced by the friction? Friction produced, it should be minus displacement is to the right, and what about the direction of the friction? The direction of friction is to the left, so altogether it will generate 180 degree, and work done for opposite direction will be k type negative bro. Our answer should begin with minus sign, begin the dinatra. So without any calculation you can eliminate option number 1 and option number 3. Eliminate to yarba. Opposite the displacement is to the S S is taken as displacement for this particular question number 4. And what about the friction? The friction is to the left, so displacement is to the right, and friction is to the left. Your opposite nature will produce what type of work done? Negative work done will be produced. Here work done will be equal to minus simple in F into F into this will be displacement into this will be cos of cos of 180 degree. Understand? I illustrate here this will be minus F into S in the now our main function is to find out the F. Maki friction F will be equal to mu r. That means our normal direction R will be equal to F sin theta plus mg. Equilibrium must be maintained in the upward direction. The equilibrium maintained any object surface even though the force is applied horizontally or at some angle, it doesn't matter. The body will be still moving horizontally. Understand? Therefore, you have to consider that equilibrium is maintained along the vertical direction. This is pushing at some particular angle, pulling at particular angle. We have already discussed in your low motion the friction that discussed here, if the force is applied horizontally or at some angle, it doesn't matter. The body will be still moving along the horizontal direction. Move that means there must not be any motion in the upward direction or in the downward direction. So it must be balanced. Okay. So in your low motion chapters, your vertical directions it must be always in equilibrium. Whatever the case, equilibrium the logera, friction the logera, smooth surface the logera, whatever nang the loading below equilibrium must be maintained must be maintained along the vertical direction, that is perpendicular to the surface. Yagadra. Our normal direction R will be equal to equilibrium habdi up ka down ka equal within a drop. 10 Newton in the upward direction, 10 Newton in the downward direction. Okay. That's the R is equal to F. Finish. F to the cap another F. Extend force F will be equal to mu F sin of theta plus mc. Do you understand this step? Nangi low friction in the friction force will be equal to mu R ma hai na. Chalo. Nangi F की value क्या आएगा? Minus mu into this is F sin of theta plus क्या लगवा? mgm लगता bro into your displacement S. यार बा? अब मागी option दा dot जाओ इधो. It is not a dot product. Dot product नते को. It is simply the multiplication. Okay. Option number 3 sumra. Option number 4 sumra. Sorry. Option number 2 sumeko. Next up, question number 7 okay. I can't banati ko aina kano skip to mise. Question number 5, question number 6. 6 ka tinyo ho sir hairani. Question number 6 है aina hoga starting starting class था ये है देखो माना displacement vector of d होता it must be replaced with your r vector. That means you have to find out the dot product between your f dot f vector dot r vector. क्या कहता? ऐसे ही calculate होगा इधर को आई इसमें skip तो रखे. Now question can be asked from your question number 7. Question number 7 को मज़े या नंबरू ओए जानता है तो question number 7 is there माना होंगी से कहीं ना फिर diagram से कहीं क्रम diagram ना diagram ना तो graph से the graph is in between नंगी force का displacement का पीवना तो करी हंगी वागदन हंगी को अदो इताड़ी नंगी का सागी वागदन से कहीं का माने वागदन is equal to नंगी force into displacement में चप्पल तबरो चली. That means area of a graph से क्या माना नहीं length into breadth का माना ब्रा. Length तो कनाना denote तवी it is denoted by force ना denote तवी नंगी breadth तो ना कनाना denote तवी it is denoted by नंगी displacement denote तो bro तो बरो और the area will give you the work done. Understood तो उन्हें यार को आदु दी तंग सी आठा hello से the work done by the force in moving the object from x equal to 0 to x equal to 6 samla pra adu di x equal to 0 dagina x equal to 6 habadi x equal to 0 signifies the origin within a draw